Hey, today is 14th of November, and this is the daily we have right now, which is quite nice problem. So it says minimized maximum product distributed to any stores. I have seen this problem in couple of ways. I don't know where, but somewhere. So you have an integer basically, and that and stores there and product types of varying amounts, which are zero index direct quantities, where every end quantities are present the ith product type. So we have quantity where every key is a type of product. That's nice. So you need to distribute all products to retail stores following these rules. Okay, these are the rules. Store can only begin at most one product. So if there are these number of stores, let's say, so every store must have only one type of product. That's okay. After distribution, each store will have given some number of products, possibly zero. Let x be the number you want x to be small. You want to minimize the maximum number of products in the minimum. Alright, so the question boils down to, let's say you have an inventory of um, product types and you have n stores. Now you have to settle down these products into these n stores such that when you're done distributing your products, the max of any store should be minimum. So first of all, these products can be anything like any variable size, and then you have to find the exact ratio in which each store should have some product so that it will be feasible. But the good point of the story is you can give it zero product. So let's look at this example. So let's look at this one. So in this I have 6 stores, 1 2 3 4 5 6 7 11 products. So I can just give 11 here and 6 here, and this, so the max of 11 6 is 11, which is fine, an answer but not an optimal answer. The next I can do is I can do 10 here, 5 here, 1 1 here, and 0 here, 0. So now my max is 10. Now I can do 9 4 1 1 1 1. The answer is 9, and then so on. So what you can see is I'm subtracting the values in very arbitrary manner, which is like I don't know what I'm doing, but as the problem set is very small, so I can decrease one by one. But if there are like 1e5 like quantities, then you cannot do that. So we have to find a exact, like what should we subtract from 11 so this fits in optimal manner. You can use maths, I guess, like you know how long one store should, like one product should be distributed so that all products can be distributed within the n store, which is why like we are doing searching, then binary search comes in the mind. That is like the intuition comes in the mind that we are trying to the optimal x and one of the ways that I solve this problem is like this is a very classic binary search problem. Let's say yeah, 6 stores again, 3, 6, and have 11 and 6. So what the minimum I can have? 0. Max I can have 11. Right, this is my low value. This is my high value. So current mid I will get is 11 plus 0 upon 2, that is 5. And put 5 here, 5 here, 1 here, 5 here, 1 here. And these are from first source, the second quantity product type. Now if we go again, now as I have shown this earlier, that if we can do with the larger amount, or if I could do with a smaller amount, we say you can always do with a larger amount. So the true one is like the truth vector of this problem is like this, and we have to find the last truth value. So now as I can do with the 5, so I can always do with the 5 to 10, 11. So I'm not going to search in this space but in this space. Now my mid will be 2, which like I can like 2 here, 2 here, 2 here, 2 here, and 2 here. This goes 5 into 2, 10, and then 1. Now I have no space for 6, which means that I cannot do for 2. 2 is my false. I cannot do for 2. 2 is not my answer. Then my new low is 2, and the previous high is 5. Now the mid will be plus 5 upon 2, that is 3, and I can do with 3, 3, 3, 3, 2, 3, 3, and this is my answer. So, and now the max is 3. So return it. So this is a very classic binary search and answer problem where you can just I mean let's say like reduce this problem into searching a finite number. You can see numerous problems as based on this topic. I'll just implement it very quickly. First I'll determine a low and a high. High would be the maximum element in the array. I could destroy a min size. Now I'll run the binary search loop. The mid value, as the values are not so much, then I can just do this. It's 25. Quite good. Then what I have to do, I have to initialize a pointer to the first, like the beginning of the quantity, so that I can start distributing from the beginning, and if I could reach the end, then this mid is suitable, else it's not. So I'll make a copy of this value. So and is yes. I'll start from first store to the last store such that my pointer is always within the vector limit, so that it doesn't causes me a segmentation fault or something. Now if my current this is my copy vector, yes, is greater than mid, like I do have this much amount of then I'll just subtract that I've allocated on the ith store. Else I'll just increment j. That means I have allocated this completely. Now I will start allocating this, and if j is quantities dot size, that is it has reached the end, that means it has generated all the quantities, then my answer is the mid value, that is the which made it possible. And now the usual binary search space. It should work unless I have done some. Yes, it is working. And it works great. Thank you.